Hello, physics class. I want to share with you a little video I am making for you about how a motor works. What I have here is a store-bought St. Louis motor. It's basically the way that all motors work, so it's a pretty important thing for you to see. And let me show you the parts and how it works. So firstly, I'm going to point out to you that we have a battery, and the battery, the positive of the battery, is attached to this electrode. And when I attach the other end of it, the negative will be attached to the other electrode. So let's start at the positive and see what happens. The current is going to go from the positive to that electrode, and it's going to go through this piece of metal here. This piece of metal here is called a brush. These two things are the brushes on either side of this cylinder in the center. This cylinder in the center is called the commutator. And actually it is not one piece of metal. If you look carefully, you'll see that there's a little gap in the middle. It's two pieces of metal that are not actually attached to each other. Each of those pieces of metal goes to this wire on the bottom, which when the battery is connected, this wire will become an electromagnet. It has a piece of iron in the middle to make it a stronger electromagnet. And on either side of it, you can see it is attracted to these permanent neodymium magnets. Well, right now, you can see that it's attracted and it's moving a little bit, but there's no current. So it's not yet constantly reversing polarity, which is what causes the motor to keep going. So how does that happen? Well, let's take a look again. So the current goes through the positive, it goes through this brush. Now, it's touching this piece of metal, this brush here is touching one half of this cylinder. And then the current is going down through this wire, through the electromagnet, and it's creating a magnet according to the right-hand rule. And that magnet is going to cause an attraction between the electromagnet and the neodymium on both sides, because the magnets are orientated in reverse directions. You see on one side they have red, on the other side they have green, just to show you that they are opposite polarities. Now, the current goes through the brush, through this half of the commutator, through the electromagnet, and it turns. But when it gets about here, you see there is that gap, and it is going to break the circuit when it passes that gap. When it breaks the circuit, for a very split second, it is no longer an electromagnet. However, it keeps moving just because it has inertia, because it was already spinning. It has angular momentum, so it keeps twisting. And as soon as it passes that gap, the brush is now going to be attached to the other half of the commutator. And that means that the current is going to go through the other side of the electromagnet. It is going to reverse the polarity of the electromagnet. So if it was causing an electromagnet that was attracted, now it's going to cause an electromagnet that repels. So it's going around here, it's attracted to the neodymium, boom, the circuit breaks, and it keeps moving a little bit more because it has inertia. Now the circuit is reformed in the opposite direction, and it repels. The neodymium magnets are repelling the electromagnet now, and it pushes it around till it gets about here. Then the circuit breaks again, and now it's attracted again. Circuit breaks again, repelled again, attracted again, and it keeps going like that. All right, let's see it. So I'm going to attach the negative. I have to actually hold the brushes together a little bit because nothing's attached, and I have to move it a little bit out of equilibrium position. Let me also move that wire out of the way before I get started. And here we go. Take a look at it. You will see little sparks flying between the brushes and the commutator. As it passes that gap and the circuit is broken, electrons go flying. So you can see that happen. You can see that little spark. And this is an extremely important invention, and you use it every day in multiple ways. I give you the St. Louis motor. I encourage you to stop by after school and check it out yourself. Okay, that's all. Bye-bye.